Hi folks, today we're going to take a look at some examples of factoring trinomials of the form ax squared plus bx plus c, where a is not equal to 1, and we're going to look at an alternative to factoring this by guess and check. We're going to use something that is more systematic, maybe a bit longer, but it is more systematic, and that's called decomposition. Okay, so let's take a look at this example here. Okay, our first step is to find two numbers, okay, and these two numbers have to multiply to the product of the first and last coefficient. In other words, the product of a and c. So we look here, 3 times 7, so the product of these two numbers has to be 21, and these two numbers also have to add up to the middle term, b, middle coefficient of -10. Okay, so the first step in doing decomposition is to find two numbers that multiply to a times c and add up to the coefficient b. In this case here, -10. So we're going to do what we did before. We're just going to go through our list of possible factors of 21. So, you start 1 and 21. Clearly, that's not going to help us get to -10. So let's find something else. We also have 3 and 7, and this is more promising. Okay, because 3 times 7 is 21. Don't forget, you also have -3 times -7 is also equal to 21, and I believe those are going to be more helpful in adding up to -10. So since we have to add up to -10, both of these are going to have to be negative, and let's see if that works. -3 minus 7 is indeed equal to -10. So we found our two numbers, -3 and -7. Okay, and this is where this procedure differs from what we did when a was equal to 1, because now we bring in the decomposition part of the process. So the first term and the last term are going to remain the same, but what we do is we rewrite this middle term, -10x, we rewrite it as -3x minus 7x. Okay, and then we still have the plus 7. So notice these two expressions are equal. All I've done is I've rewritten -10x as -3x minus 7x using the two numbers that I found earlier. Okay, step that follows is to factor out the first two terms and the last two terms. So here, when I look at the first two terms, I see that they both have a common factor of 3, and they have a common factor of x. So when I factor out 3x, what am I left with here? Well, I'm just left with x. And here I'm left with, well, I've taken out both 3 and the x, so I'm just left with -1. Okay? Now we have to factor the last two terms. Okay? This is where I want us to remember that sometimes it's more useful to factor out the negative version of my common factor. Okay? So what I'd like to have in my bracket is I'd like to have x minus 1, like I have on the left-hand side. So I'm not just going to factor out a 7, I'm going to factor out a -7. And what are we left with here when I take out the -7? Well, I'm just left with x. And here, when I take out the factor of -7, well, 7 divided by -7 is -1. And here we see why this works, because once I've done this double factorization using common factors, I see that there's a new common factor of x minus 1 from both expression to the left and right of the subtraction. So I can take out the common factor of x minus 1, and I'm left with here 3x, and then from the second expression I'm just left with -7. Okay, and there we go, that's our factorization. Let's check quickly that it works. X times 3x is 3x squared. Let's do the outside and inside terms. -7x minus 3x is -10x, and then -1 times -7 is +7. Okay, and this is how decomposition works. So let's just go through a couple of more examples. Let's look at example 2 here, and in this case I'll take 4x squared plus 4x minus 3. So again, now I'll go a little quicker. So I need two numbers, p and q, that multiply to a times c. So 4 times negative 3, so they have to multiply to negative 12, and they have to add up to the middle term, 4, so p plus q has to be equal to 4. Okay, so let's go through our factors of 12. Well, 1 and 12, that's clearly not going to work. 2 and 6, okay, that looks more reasonable. So here they have to multiply to negative 12, so 1 must be positive, 1 must be negative, but they have to add up to positive 4. So I figure out that the 2 has to be negative and the 6 has to be positive. Now, if you're having difficulty doing this step in your head, just do these checks in your calculator. Just check which one will give you the right answer. So negative 2 plus 6 is 4, negative 2 times 6 is negative 12. So those are my two numbers. Now let's go and use those numbers to do the decomposition. So 4x squared doesn't change. I'm going to rewrite the middle term, 4x, as minus 2x plus 6x. Okay? The 4x is equal to this expression, so that's why I can just replace it. And then the minus 3 doesn't change. Okay? The next step, remember, is to factor the first two terms and factor the last two terms. So I look at the first two terms. They have a common factor of 2 and a common factor of x. So 2x. What am I left with here? If I take out a common factor of 2x, so I've got 2x in this first expression that's left, and here I take out the 2 and the x, I'm just left with minus 1. Let's now factor the next two terms. They both have a common factor of 3, so I'm going to factor out positive 3, and what I'm left with here is, well, I take out the 3, so I'm left with 2x, take out a factor of 3, I'm left with minus 1. Okay, and this is how I know I've done it correctly, because we have a 2x minus 1 on the left and a 2x minus 1 on the right. So that's my common factor at this stage, and we're left with 2x from the left and plus 3 on the right. Okay, and there we go. Now let's again check that the answer is correct by expanding. So 2x times 2x, 4x squared. Good. 6x minus 2x, positive 4x, that's good. Negative 1 times 3 is negative 3. Okay, so let's move on to a third example. And you're going to see that the procedure is the same every time. So as I said, this is a little longer than guess and check, but you can follow a system that will work every time. Okay, so let's take a look at 6x squared minus 13x plus 5. Okay, so again, I'm looking for two numbers that multiply to a times c, so 6 times 5, so that's equal to 30. And these two numbers have to add up to the middle term, negative 13. So again, let's go through our possibilities. Well, 30, well, 6 times 5, but with 6 and 5, there's no way to get to 13. Okay, so let's try 2 times 15. Okay, 15 and 2, that doesn't work either. That's, oh, actually, you know what, that might work. Let's take a look here, 2 and 15. The problem is that the 30 has to be positive, meaning they're both positive, so 2 plus 15, well, it's not negative 13, or they have to both be negative. Negative 2 minus 15 is also not equal to negative 13. So it looked promising, but it didn't work. Okay, so let's try another one. See here, sometimes the bigger the number, the more things you have to check. I also have 3 and 10. So remember, both positive and both negative, or both negative. So here I look and I see negative 13, and I realize, if I take negative 3 minus 10, that is equal to negative 13. So notice this is why you have to be very careful with the signs, because you might have a situation where it looks promising, but it doesn't work. So that's why you always need to check these additions and subtractions. So now I've got my two numbers. So we're going to rewrite 6x squared doesn't change, and we're going to rewrite the middle term. Instead of negative 13x, I'm going to write negative 3x minus 10x. Okay, again, since these things are equal, I can just replace it into the expression, and the plus 5 doesn't change. So please notice, it's only the middle term that gets the decomposition. So here, now, next step, and look how I use my brackets to help me out here to see that I'm factoring out the first two terms. So I look 6 and 3, common factor of 3. They both have an x, so common factor of 3x. Remove the 3x here, I'm left with 2x. Remove the 3x here, and I'm just left with the minus 1. Okay? Be careful, again, I've got this negative in front, so instead of just removing a common factor of, well, I see 5, I'm actually going to remove a common factor of negative 5. Because what I want left in the bracket, I want it to be positive, just like what I have on the left. Okay, so let's see what I have here. When I take out negative 5, I'm left with positive 2x. And when I divide 5 by negative 5, I'm left with minus 1. And yet again, I know I've done it right because I've got the same expression, 2x minus 1, on both sides of this larger expression. So the common factor, 2x minus 1. And what am I left with here when I take out the 2x minus 1? I'm left with 3x. And here I'm left with minus 5. Okay, and let's check this again. 2x times 3x, 6x squared. Negative 10x minus 3x, negative 13x. And then negative 1 times negative 5 is equal to positive 5. Okay, and let's do one last example here. Okay, we'll use another sheet of paper. Okay, the last example I'm going to work on, and we'll take maybe some slightly bigger numbers. So example 4 is going to be 6x squared plus 13x plus 6. Okay, so again, I'm looking for two numbers that multiply to a times c. So 6 times 6 is 36. And the two numbers have to also add up to the middle term, which is 13. Okay, so let's start here, 36. Now what's nice is everything is positive, so I know I don't have to worry about any negative numbers here. So let's start here, well, let's start 6 and 6. Well, 6 plus 6, that's not going to give me 13, so that's not going to work. Okay, 36, so I've got 12 and 3. That's also multiplies to 36, but with 12 and 3, there's no way to get to 36. 2 and 18. Okay, again, 2 and 18, nowhere to get to have them add up to 13. So sometimes you have to try a few before you get to the right one. Okay, 4 and 9, that's equal, that multiplies to 36. 4 and 9, that looks a little more reasonable. So if I take positive 4 plus 9, that's equal to 13. So here, remember, the first term, the x squared term doesn't change. It's only the middle term that gets the decomposition. So I'm going to write 13x as plus 4x plus 9x. And then the plus 6 doesn't change. Okay? Group together the first two and the last two terms. Let's find a common factor here. So 6 and 4. So the common factor is 2 plus a common factor of x, so 2x. And let's see what we're left with when we take out a factor of 2. Here we're left with a 3, and there's still 1x left over. Here when we take out a factor of 2, we're just left with 2, and the x has been removed completely, so no other common factor. Let's now do that with the last two terms, and here 9 and 6, they have a common factor of 3, so positive 3 in this case here. When I take out the common factor of 3, what do I got? 9 divided by 3 is 3. X plus 6 divided by 3 is 2. And as expected, on both sides of the expression, I have a common factor of 3x plus 2. What are we left with now when we take out that factor of 3x plus 2? We have a 2x on the left plus 3 on the right. Okay, and let's do a quick check here. 3x times 2x is 6x squared. 3x times 3, that's 9x, plus 4x, and 9x plus 4x is indeed equal to 13, and then 2 times 3 is equal to 6. So that's the correct factorization. Okay, so let's recap. When you're using decomposition to factor out a trinomial, okay, don't forget, by the way, to always look for a common factor first, because that might simplify things. Okay, but in a case like this where there's no common factor, Step 1 is find two numbers that multiply to a times c and add up to the middle term b. Once you find those two numbers, you use them to decompose the middle term into two separate x terms. Okay. Next step is to find a common factor for the first two terms, and then a common factor for the last two terms. And then once you do that, you should have a binomial that's common to both sides of the expression. Factor it out, and then in the other bracket, write whatever's left. Okay, so try to do several examples as practice, and again, if you want to give guess and check another try, you can try that too.